Hello everyone and welcome. My name is Matt Piper and I'm the Global Industry Solutions Director for Utilities, Water and AEC at Esri. I'm excited to be here today presenting to you on ArcGIS, the foundations of digital twin, because it is a topic I'm really passionate about. And I'm looking forward to sharing some of my personal experiences in the utility industry and also hopefully shed some light on many of the recent advancements in GIS technology as it pertains to digital twins. Now, as you're aware, utilities are continuously faced with unprecedented challenges. For many, it's a combination of known issues around things like aging infrastructure and then the unknown or the unforeseen impacts due to things like natural disasters or even the COVID-19 pandemic. But in addition to these, utilities are under more pressure than ever before to change their operating models, to change their processes, and to change their behaviours as a result of these constant technology advancements. This constant change requires better understanding and better communication, better collaboration, and a need for better decision making. And while the utility industry has been notoriously slow in the adoption of change, it has been said that it has seen more change in the last 2 decades than in the previous 100 years. And I was thinking about this from my experiences working at a power utility, and I thought I'd take some time to reflect on this and recap on some of these larger transformational programs of work that I've experienced in this time as a result of these shifts in technology innovation. Now, it may be hard to believe, but you need to go all the way back to 1999 or the 2000s to when this new concept of IoT was first introduced. Now, I remember reading about this and thinking, this is an amazing technology. It's going to connect everything to everything else, with a premise to create new insights, improve situational awareness from all these interconnected things. But unfortunately, the IoT revolution was fairly slow to gather momentum, which was largely due to the lack of supporting infrastructure, the high costs, and the large processing power required to deploy these sensor networks. As a result, it took around 3 to 5 years for the utility industry to embrace and prepare for this IoT technology. And in around 2004, I remember working on my very first smart grid project. I was fortunate enough to work at a utility that was able to secure funding, and millions of dollars were invested to roll out this advanced metering infrastructure, or smart meters, with a promise that was going to improve your reliability, give customers choice, and implement new grid intelligence through things like self-healing networks and automation. But in reality, it was really difficult to achieve any sort of initial return on investment. And this was largely due to the data tsunami that we were hit with. Like many utilities, we did not have a plan on what to do with all this data. And I remember being introduced to some familiar terms now like data lakes or big data or even data swamps. In the late 2000s, we began to see the emergence of a new program of work around grid modernization. There were numerous facets to this, but it was largely a reaction to the need to upgrade the aging infrastructure and to create solutions to manage the modern grid, including things like distributed energy resources and microgrids. Grid modernization was also tasked to break down organizational silos and bring together this notion of OT and IT convergence. This was the bringing together of operational data from systems like SCADA with other corporate data which might exist in your ERP or even your GIS. These projects also experienced significant setbacks due to the multiple data sources that exist, legacy integrations, and custom applications. And of course, let's not forget about the poor data quality. In 2012, we began to see the adoption of mobile devices into more corporate enterprise workflows. I remember deploying the first rugged toughpads to the field, which replaced many legacy paper workflows. This also resulted in an increase in the development of mobile apps and saw the use of personal devices on the corporate network increase. This was also known, if you remember, as the BYOD. I also recall the struggles that large-scale digital transformation programs had that were not due to the technology limitations, but they were more due to the people, the processes, and the inability to transform the way that they did work. In late 2016, the Paris Climate Agreement was signed to curb the release of greenhouse emissions. The Climate Change Initiative has been signed now by more than 190 countries, and many utilities around the world are embarking on energy transition projects to reach strategic decarbonisation targets and to deploy green energy solutions. And while many utilities are in the early stages of incubating this strategy, we are already seeing great successes coming from the early adopters, particularly in countries in Europe. And finally, the latest driver in the industry is this resurgence of digital twins. And I say resurgence because digital twins is not a new term for utilities. In fact, the term digital twin has been around since the early 2000s. But at a global scale, we are now seeing more and more requirements to deploy these digital twins for utilities' networks, their assets, and their facilities. So let's look at this definition of digital twin and the role that GIS plays. As many of you are aware, a digital twin is the virtual representation of the real world, including the physical objects, the processes, the relationships, and the behaviors. And GIS creates digital twins of the social, natural, and built environment, and it uniquely integrates many types of digital models. Now, I find this definition very interesting, but it does get me thinking. Now, I've been a long-time user of GIS, and I can't stop but help and ask myself, isn't this what we've always done? Isn't this what GIS is today? Well, GIS allows you to model the environment and the topology, and it creates a digital representation of the network, and it allows you to gain better understanding so you can take action. So I hope this resonates with you from all of your experiences as well, as this is something we have always done in GIS, well before even the IoT came in the early 2000s. But just as the drivers of a utility have changed over time on these technology advances, so has the requirements of digital twin. And as a result, so have the capabilities of a modern GIS beyond just the visualization or digitization of our networks. Let me give you an example. I remember deploying a digital twin project about 10 years ago, which involved flying the entire network using aerial imagery and LiDAR to create a 3D spatial representation of the entire grid in spatial context. And at the time, this was our digital twin. It was cutting edge. But guess what? Not long after it was deployed and the business began playing with it, they wanted more. They wanted to interrogate it. They wanted to integrate it with asset management systems. They wanted to gain more insights, but it wasn't possible. It wasn't interactive. It was a static, single representation built in isolation. What's more, not long after it was created, the data was already out of date. This is exactly why digital twins are evolving with GIS as the framework. A modern digital twin is a powerful tool. It allows you to abstract and model everything, bringing together many different information models. We see this in four main ways. The first model is the land-based or the environmental model. This is the terrain, the topographic, and the environmental layers. In recent years, we've seen the accelerated development of BIM, or Building Information Models, allowing users to model accurate and highly detailed representations of structures, plants, and facilities. Then we have the information models of managing networks. Typically, these models manage the linear assets and the connectivity. So for utilities, this leverages the ArcGIS utility network, which is the most advanced data model available in the market today. And finally, we have the city information model, which allows for bigger picture modeling at scale. This assists in workflows for urban planning, citizen engagement, and more recently, smart community initiatives. If you look at these information models, it is clear that they're all different. And each one on its own, by definition, could be a digital twin that can be used to solve many business challenges. But what ArcGIS does that no other technology can do is that it integrates and it connects all these different types of digital twins. GIS can be the digital twin, right? But in other cases, it's just the enabling technology. It allows the interconnections of all these other digital models, which creates additional value to the customers by providing a more holistic view. This is really exciting, and it's unique to the power of ArcGIS. Nothing else has this capability to connect very detailed BIM models to the larger networks, allowing you to trace from inside a BIM structure out to the upstream networks. Then also see this in context to the larger city views. Let's look at how GIS does this across the life cycle of a digital twin. If you recall the definition we discussed earlier, a digital twin includes interconnecting the content, the behaviors, and the workflows to solve many of the challenges utilities are facing. And I just mentioned, it's all about interconnecting these different information models. One of the biggest changes in mindsets for IT architects is that an integrated digital twin is not one single solution or product. It is an ecosystem of capabilities and applications which are being brought together by GIS to support holistic and collaborative approaches. It's not one digital twin, but rather many digital twins that are integrated and interconnected. One of the powers of GIS is that it creates relationships and streamlines workflows. Everything has a location, right? So location becomes the common key to integrate these siloed solutions and allows for the modeling of the complete lifecycle. Data capture and integration is foundational to a digital twin. It is about being able to model the data capture, integrate it, manage it, and then associate all the attributes and behaviors throughout the entire lifecycle. Next, it's about bringing the data to life, right? Taking this information and creating a better understanding on what is happening now. It is about creating a real-time situation awareness combined with those advanced visualization capabilities to virtually represent the physical components and how they're operating in the real world. But as you know, digital twins have moved beyond just the current operational states. They are about understanding the past and also predicting the future, being able to simulate and forecast expected outcomes, as well as automate the decision-making process. And finally, digital twins need to be pervasive. They need to be accessible on the desktop, on mobile, and they also need to be made available both internally and externally to stakeholders. Digital twins are about sharing and collaboration of information to make better business decisions. Let's go a little bit deeper into each one of these topics now. Now, from my experience, data quality has always been a challenge for utilities. It is difficult to capture, and it's more difficult to maintain and keep current. And if it's left unresolved, poor data quality will result in lost time, it results in duplication of work, and it erodes the trust in your business ability to do accurate reporting and analytics. In recent years, there has been significant investment in GIS to better enable data capture, integration, and management. The reality capture technology allows data capture at scale and with high accuracy. 3D imagery technology can provide full network capture through LiDAR and mesh. And networks can be created and interacted, and now through 3D, you get feature extractions. With the release of the ArcGIS utility network a few years ago, many utilities are already taking advantage of this new data model. Now, there are many advantages to why the utility network is transformational for organizations. But some of the most important things for me is that it's configurable to hold your network logic and your business rules. This inherently means your data is maintained accurately both in the office and out in the field. The utility network also allows you to model the entire network. It allows you to model from the generator all the way to the customer. And as it's 3D enabled, it also unlocks many of the additional capabilities of a modern GIS. It allows you to model substations in 3D and see how they are connected to the rest of the network in a spatial context, both above and below the ground. And finally, if you look to the bottom right of the screen, you see how GIS is integrating information models and systems together. In this example, a facility was scanned with LiDAR. This scan was then converted to a BIM model, which allowed detailed visualizations and attributes to be associated. In addition, this information was then integrated to the asset and works management systems to bring up additional asset information. And the work order details for that asset component were made available to everybody, showing a fully integrated workflow from data capture, modeling, and integration. The need to be able to model and visualize how assets, structures, and networks are operating in real time continues to increase. In 2020, there are now more than 50 billion IoT devices connected globally, and organizations are needing to bring these critical data sets together to support real-time awareness and decision-making. One of the biggest areas of concern for many utilities is the as-built process. It is common to have significant information latency as jobs are backlogged, waiting to be updated into their corporate systems. GIS now is essential to the delivery of these construction projects. It provides advanced visualization of complex and big data sets to aid in streamlining these workflows. At the top of the screen, you see a representation of a bridge construction, which is tracking the delivery of the project in 5D. So 5D is 3D with the addition of time and cost. And at the bottom of the screen, we see another great example of BIM and GIS integration. It's all in 3D. However, this time, it is configured in an operations dashboard, which is also connected to real-time operations data, bringing together a holistic view for managing that site. Another area of significant development in recent years is the way that GIS is analyzing and providing insights for these future outcomes. GeoAI and advancements in machine and deep learning are transforming digital workflows and automating many of the processes utilities are using. These tools for object classification, like determining solar panels on roofs, or even suitability analysis for site selections. But they are also using these image classifications for things like 3D damage assessments following natural disasters, or using the AI and the machine learning to train models to manage vegetation encroachments and optimize other spatial maintenance programs. And finally, GIS is being used to assist in predictive modeling, looking forward to the what-if scenarios. It provides the capability to run predictive analytics on future failures, and this is based on historical records. And it will even improve your work plans for tasks like route optimizations. As digital twins continue to evolve, so does GIS technology to meet these challenges. An area that GIS plays an essential role is how it supports the sharing and collaboration. GIS is essential to providing the necessary capabilities to take the information captured and analyzed and then share it to all those who need it in a dynamic and visual way. The data is secure, and it can be shared in collaborative ways both internally and externally, which improves information latency and citizen engagements. A great example of this is shown below. This is a story map showing a large-scale project in Australia. Not only was GIS used to manage the project delivery in great detail, it was also used as a way to keep the public up to date about the project progress via a story map. Now let's look at a few other industry examples. The telecommunication is moving fast, and telecommunication companies need to make intelligent decisions and ensure services are delivered via next-generation network management. The ability of a company to successfully deliver today's next-generation networks is dependent upon the quality of data available to them and how they plan and deliver network capable of providing the highest quality and services that the customers demand. Through the utilization of GIS technology, digital twins are being created to support things like 5G and fiber rollouts. An example of this is shown at the top left of your screen. Planners and engineers require highly accurate landscape, building, and network information in order to make the best decision for a fiber design of 5G small cell deployment. By leveraging a digital twin, engineers can design with spatial accuracy and perform line-of-sight analysis for optimal network designs. Telecoms can integrate to detailed CAD files, allowing for highly detailed models to be visualized in context. Here you can see how the cell tower is interactive, and it allows you to be tracing both upstream and downstream, showing the end-to-end connectivity. And this connectivity can be traced all the way into a building, modeled across the building floors and all the way into the racks and the ports of the network, and then visualized in easy-to-manage schematic views. This is amazing stuff and shows the power of this technology and the full end-to-end network management for telecoms. Now, for electric utilities, the story is just as amazing. And I have some great examples to show you here as well. Organizations are using GIS to better understand and plan for events like natural disasters. Understanding precedes action. And by knowing where areas of your network are prone to things like wildfire, earthquakes, hurricanes, it allows you to plan more effectively. This planning can be optimized by only understanding potential impacts to your network, but also planning evacuation routes or even the staging areas. Real-time outage situation awareness is essential, and GIS becomes the operational dashboard for aggregating and monitoring things like outage events. This information is delivered in easy-to-understand reports which can be shared internally and also externally to aid in the information transparency and decision-making. But what is most exciting for utilities is how they are now embracing 3D capabilities. I remembered having to deploy a separate mobile solution for substation maintenance programs, as the GIS at that point in time represented the substation as a single dot on a map. This meant that the hundreds of assets that existed at that site were all in the same spatial location. Once again, with the deployment of the utility network, these can now be visualized accurately using containments and in 3D. But this is now being further extended to integrate to other design solutions, bringing in interactive 3D models, which not only look fantastic, but they also streamline many workflows and create new opportunities. We can see that GIS is creating value across many different industries as it begins to interconnect all things infrastructure. From being able to model the full underground networks in Rotterdam in 3D, to modeling highly accurate and detailed water treatment plants. Or perhaps you're looking to connect your gas and pipeline for your utility network to other detailed designs. Or maybe you're looking to be able to design or interact with buildings and facilities management. GIS is the process and framework to integrating and interconnecting all these different models to create a modern digital twin. A recent survey revealed that 70% of organizations are in the planning progress or willing to implement a digital twin in the next 1 to 3 years. And leaders are beginning to understand that in order to generate the expected outcomes, they need to think geospatial. A digital twin is not a single magic solution. It is the culmination of all these things we discussed earlier. It includes the requirements of all the other information programs, such as the IoT, the smart grid, the grid modernization, digital transformation, and the energy transition. And it requires the interconnection and integration of many types of digital twins, something that can be only done and achieved with ArcGIS. Now, I hope you have enjoyed this presentation, but I'll leave you with this final takeaway. If you are considering deploying digital twins, remember, GIS is the foundation for digital twins. And using location intelligence and geospatial technology, you can redefine the art of the possible and how to solve many business problems by creating digital twins of the modern world. And with that, I'd like to thank you for your time and have a great day. Thank you.